Hello, everyone, and welcome back to the Virtual Eclipse Community Meetup. I'm your host, Stephanie Swart, and today I'm joined by Philip from Eclipse Source. We're very excited to have you, and thank you so much for being here, Philip. Today's meeting is on using Papyrus as an open source platform for building domain-specific modeling tools. So without further ado, Philip, take it away.
Thanks a lot. Hi, everyone. Thanks, Stephanie, for the introduction, and welcome everyone joining this meeting. I'm very excited to host this webinar today, and the topic is Eclipse Papyrus on the one side, and on the other side, I'd like to show you how we've used Papyrus to build customized and streamlined domain-specific modeling tools. So let me just switch to my slides for a second. I think you see my slides now. So basically, what I would like to show you is that Papyrus is not only a UML tool, but a platform for building domain-specific modeling tools itself. And our background is basically at Eclipse Source that we are. 1 second, I can't switch. Oh, no, it works. Sorry. So what we are mainly doing at Eclipse Source is building modeling tools together with our customers based on open source technologies. And we use for building these modeling tools on the one hand side, of course, the Eclipse Rich Client platform, and on the other hand, Eclipse modeling projects, and all these different variety of technologies that build on top of the Eclipse modeling framework. And since our customers and projects are across several different domains, you can also imagine that also the modeling tools that we build look very different depending on which domains we are in. So on this spectrum of different modeling tools that we are working in it goes from these more typical software engineering and systems engineering modeling tools where often graphical models are involved, through to more business application like information systems and tools where the user interface is, for instance, more form-based and the workflows are more business-oriented. And still we are using in these tools modeling technologies, but it's not a typical modeling tool where you have like graphical modeling included in itself. So as you can see, here we have on the left-hand side these graphical modeling tools. A lot of them in the systems engineering and software engineering domain also use UML, and this is exactly the domain where I would like to dive into more in detail. So in our experience from introducing modeling tools in several different organizations and domains, one of the key success factors of model-based engineering, that means using models to accomplish a certain goal, is that the modeling tool and the modeling environment should be as domain-specific as possible. And what that means is that we would like to build highly customized modeling environments that directly reflect the specific needs of a particular domain and, of course, its users that work in this domain, taking into account the roles and backgrounds that these users in the domain have. So, for instance, system architects, of course, need some other ways to represent and work with models than, for instance, electrical engineers or firmware developers. Also, these modeling tools need to support domain-specific methodologies and workflows to directly fit into the daily tasks of these domain users. And an important aspect for developing domain-specific modeling environments is that the focus should not only be on the domain-specific modeling language, as shown here, because a domain-specific modeling environment consists of several different parts, and of course the user will only judge the usability and the usefulness of this domain-specific modeling tool in its together with all the other aspects. So that means we have the domain-specific modeling tool, which of course, domain-specific modeling language, which of course is very important. But of course, there needs to be an editing environment and a tooling around this domain-specific modeling language that allows the domain user to efficiently interact with this domain-specific modeling language. And of course, we don't want to only use modeling by a means of itself, but usually we apply models to accomplish a certain goal. And therefore, we need, on the other hand, a couple of components, for instance, code generators, validation components, and simulators, stuff like that, to make use of these models and to produce some artifact out of it that then can be, again, used for the particular domain task by the domain user. In the domain of graphical modeling, that means that graphical models in this domain-specific modeling world may look like here, these examples on these screenshots. So that means we have domain-specific shapes that make some sense for the domain users, and these shapes represent the structural model in the background. Very often, when we start with a project at an organization where we want to introduce domain-specific modeling, people very often immediately agree that we need some sort of domain-specific modeling language, but then some sort of discussion often arises. And this discussion usually goes like as follows here on this slide. So basically, we can agree on a domain-specific modeling language, but then, of course, someone points out that a part of this domain-specific modeling language, somewhat looks also like UML, for instance, state machines or interactions or whatever diagram might be very similar to a part of this domain-specific modeling language. Then the other side again argues, okay, maybe that could be the case, but of course, in this domain-specific modeling language that we just designed and want to develop now, there is a lot of things that aren't covered by UML. So when you look at this chart here, and you know you want to achieve this domain-specific modeling language, then of course there is a part that might be covered by UML, but there is of course a lot of things that aren't covered itself. But of course, for the part that is already covered by UML, we don't want to reinvent the wheel for the part, right? Of course, the counter argument is, yeah, maybe we don't want to reinvent the wheel, but of course, there is also a lot of things in UML that we don't need. And if we use UML, we get them whether we want to or not. And then, of course, you could argue, okay, we could just not use this part, but then, of course, this comes at the cost of usability because that would confuse users if the domain-specific modeling language would include UML, and there is a lot of things that are not streamlined for a particular use case or for a particular domain. So that's not ideal. However, in this question and this discussion whether to use UML or to not use UML, it actually is not, if you look at the arguments in detail, it often is not really a discussion about whether we should use a domain-specific modeling language or UML. What these arguments are really about is whether we should use a domain-specific modeling tool or just reuse an off-the-shelf tool. And of course, when you look at this comparison, then it's clear that a domain-specific tool will always better fit a particular domain and a particular use case than an off-the-shelf tool. But also, if we build a domain-specific modeling tool, that doesn't mean that we can't still build on top of UML and reuse those parts of UML that we actually would like to reuse, as long as we would have a UML modeling platform and not an off-the-shelf UML modeling tool. And that's exactly what Papyrus is. Papyrus is in many ways not only a UML tool, but in fact a UML modeling platform that can be used to build domain-specific modeling tools based on parts of UML. And actually, a lot of all of these pictures that I showed you before of domain-specific diagrams are actually screenshots of Papyrus in a very customized way. So showing basically UML or extended UML models with customized and domain-specific shapes. So in case you don't know Papyrus, just a few words about that. Papyrus is an open source UML modeling platform published under the Eclipse public license, part of the Eclipse Foundation Eclipse modeling project, and it's based on the Eclipse modeling platform itself. It also reuses a lot of modeling standards. Of course, UML is one of them, but also SysML, OCL, FUML, and ELF are other standards. So being standard conform is a very important part of the Papyrus project. Papyrus is supported by a very large open source community, so there is a lot of committers and users out there who are working together to use and extend and enhance Papyrus. And all these efforts are also governed by an industry consortium, the Papyrus Industry Consortium. But I will come back to that at the end of this talk to give you a few links to what this industry consortium does. But besides being all this Eclipse modeling, UML modeling tool, it really more and more focused on, in the recent years, focused on being a platform that allows to build domain-specific tools based on UML and SysML. So how does that work? How can we use UML and still add something domain-specific on top of it? Of course, UML is a general purpose modeling language. So how can we add on top of this or turn this general purpose modeling language into something domain-specific? Well, there is an inherent extension mechanism built into UML, which is called UML profiles. And this extension mechanism allows you to extend UML with domain-specific concepts. So if you remember this chart that we had on earlier slides, where you have this your domain-specific modeling language, and it has an overlap with the language extent of UML. You could also look at it that way, so that you have your domain-specific modeling language, and there are parts which directly reuse or at least build upon UML. And then you would like to have something domain-specific on top. And exactly this part that you would put on top of UML is done by using UML profiles. Of course, this is not only true for UML profiles, but also, not only true for UML, but also for SysML, which itself is an extension of UML by the means of a profile. But that doesn't mean that you can't extend it the same way as you could extend UML itself. So the UML profile mechanism allows you to also take an existing UML profile and add additional things on top of even this UML profile. So you can also just base your particular domain-specific modeling language on SysML rather than UML. If you are in the systems engineering domain, for instance, that could be something worth considering. Of course, when we now created our domain-specific modeling profile on top of UML, we only looked at the domain-specific modeling language. So that means the structure of the model, if you want to call it like that, the meta model. And this already allows you to have some sort of generic syntax for these for your UML profile. But that doesn't mean that doesn't bring you already the benefits of a domain-specific modeling tool, because there is a lot more to a domain-specific modeling tool than just a domain-specific modeling language. And for that, we of course need things like domain-specific tooling, like a specific graphical syntax. We need specific tools to create specific modeling patterns or elements. And we need a rich client platform to support the domain-specific workflows and to help users interacting with those models. And finally, as mentioned before, we need to build components that make use of those models and fulfill a certain task, like code generation, validation, analysis, and stuff like that. And therefore, to implement those components, we need an easy to use API to process these models. So putting that into picture, that means we can now take this domain-specific profile that we just created on top of UML and reuse those parts that we would like to have from UML, and you make also at the same time use of a UML platform and put domain-specific customizations on top to, for instance, also allow you to have domain-specific tooling for editing the models and so on. And then we should be able to build components that take models from this platform and process them in some way, for instance, code gen and validation and stuff like that. And all these tasks are perfectly fulfilled when you use Papyrus and as a platform. And the reason for that is that on these different levels of customization that we just talked about, so editing, processing models, and adding workflows, for instance, that are tool supported, we can use the different extension mechanisms that are available on, for Papyrus, but also on EMF level, as well as on the Eclipse Rich Client platform level. So for instance, Papyrus offers us customizable graphical syntax mechanisms, so that we can change the graphical syntax of these domain-specific models based on UML. And it allows us also to customize the tooling So for instance, to have an own palette that really only represents what we need. And we have own property views that only show the part that is of interest for a particular use case or domain. We can also affect the editing behavior. So for instance, what should happen if I double click something in a model, and so on. Since Papyrus is built on EMF, it provides us a very, very good foundation for processing models. So EMF, the Eclipse modeling framework, is a very, very mature framework that has been there for decades nearly. And it is a very nice API. It provides you a very nice API to read in models and then process them in some way. So for instance, to generate code out of it using, for instance, extend, to analyze it by traversing it and computing, for instance, metrics from the model, or by even simulating it or running validation constraints on it. One other big benefit of Papyrus being based on the Eclipse modeling framework is that it's interoperable with any other EMF-based tooling. So that means if one part of your domain-specific modeling environment is based on Papyrus, you will end up having plain EMF models, and you can build another part of your domain-specific modeling environment built based on another EMF technology. So for instance, you can use Xtext or Sirius to provide textual or other graphical modeling tools and integrate them directly with the models that you created with Papyrus or based on Papyrus. And finally, to implement a workflow that fits the requirements of your users, or to integrate it with existing infrastructure, you can make use of the Eclipse Rich Client platform to, for instance, create toolbars, wizards, menu items, and so on that support the user to really apply their workflows that are important in their domain, and maybe also integrate other knowledge sources or artifacts from internal databases and stuff like that directly into the modeling tool. So that brings a lot of flexibility to make your tool very domain-specific, even though you're building on top of UML. So there is no contradiction between domain-specific tool modeling tools and UML modeling tools anymore when we are using an open platform like Papyrus. So to make this more concrete, so that was the theoretic introduction, I would say. To make it more concrete, I prepared a small example that we can look up, look at to have an example of how these different aspects that I mentioned before really look in practice. And what I would like to show you is basically one way of creating a domain-specific modeling tool based on Papyrus for computing average durations in workflows. So our domain is just workflow management, let's say. That means we would like to have a workflow modeling language where a workflow contains tasks. So I have here a mock-up of the model or the diagram that we would like to achieve. So we have a workflow, and this contains a couple of tasks. These tasks can either be manual tasks like send forms here, or they can be automatic tasks like send form here, or manual tasks like this check send forms. And then there is can be a flow between tasks, and there can also be parallel flows and decisions like we have down here, so that after test checksum, we can either go that way or that way in the execution. And to specify which way is more probable, we would like to annotate probabilities on these branches here. So that's our example that we would like to accomplish. So how does that work now when we want to build it on top of Papyrus? So first of all, we need to think about how the meta model would look like for our domain-specific modeling language. And that is very, you don't have to really create the meta model, but just in your mental picture of your domain-specific modeling language, you have some sort of structure of this modeling language in mind. And this could look like this eCore diagram, basically, where you have the physical structure of this modeling language. So we have a workflow, which encaptures this whole entire workflow. Then this workflow consists of workflow nodes. So any of these things that are in my workflow are workflow nodes. These things in the workflow can either be tasks, like these two here. They can be decisions, like this part here, or they can be flows, like the connecting lines between those tasks. And now, when we would like to reuse Papyrus, what we would then usually do is to see if there is some sort of mapping to the UML language. And this is crucial. If there is a reasonable overlap with UML, then it definitely pays off to have a look at basing your domain-specific modeling language on UML. If not, then probably other technologies like Sirius might be a better choice. But in many cases, a lot of domain-specific modeling languages certainly reuse a part of UML. So in these cases, it's still a very good idea to have a look at Papyrus, for instance, as a platform to implement your domain-specific modeling language. In this case, luckily, we have pretty much a pretty large overlap with UML. So for instance, the workflow is very, very similar to an activity diagram, and a task could be represented by an action in this activity diagram. An activity diagram already has decisions and has control flow, so we are already pretty well equipped here. So what we then would just need to do is to extract the parts that are not covered by UML. And in this particular example, this part is basically, we can't represent in an activity diagram whether something is a manual task or an automatic task, and we can't represent, for instance, the probability of a flow, whether it's low, medium, or high, for instance. So with that red marked areas, this is exactly what we would then have to represent on top of UML in this domain-specific profile. So how that works in Papyrus is that you can simply create a profile. I will show that in a second in the tool, and then select the parts of UML, the concepts, or also called meta classes of UML, that you would like to extend, and then create so-called stereotypes that introduce these additional concepts to UML. So for instance, in our example, we said that these tasks are represented by action, but we would like to distinguish between manual tasks and automatic tasks. So what we would do is we would just import action and create a stereotype that can either be an automatic task or a manual task. And then these stereotypes not only tag specific elements and extend them, but they can also introduce specific additional properties, like a component that automatically that executes this automatic task, or an actor that is responsible for a manual task. So let's have a look at how this looks like in Papyrus. So what I've created here is a plain UML activity diagram. So you can see Papyrus, vanilla Papyrus without any customization. I've just created this this activity diagram that represents the workflow that I've shown also on the slides. So what I would like to do now is just to show you how to create such a profile and how to extend this this UML part that we would like to reuse. And to do that, I would just create a new Papyrus project. And now select that we would like to create a profile, not a UML model, but a profile. We can then give it some name, like workflow profile. And we would like to initialize this model with a profile diagram. Finish. So now what we get is an empty canvas where we can start to create our profile. And as I mentioned before, one thing that we would like to, for instance, be able to express in our domain-specific modeling language is the probability of control flows after a decision. So I just click here on one of these control flow on one of these flows, and it tells me already that this is has the type control flow. So in order to extend this particular type, I can here click on import meta class and search for control flow in the list of types in UML, double click it and hit OK. And now I can start to extend it by creating stereotypes. So let's just create here a stereotype and call it weighted flow And in this weighted flow, we would like to be able to specify probabilities. So I just create an enumeration here, which represents the probability. This probability can be, so for instance, low, or let's take a simplicity, or high. And now we want to be able to add this information to any weighted flow. So I just create here a property called probability, which is of type probability, and we only want to store 1 or 0, 0 or 1 values of these probabilities. So that's basically done. The only thing that is left to do is to specify that this stereotype extends the meta class control flow. So as soon as we store that, we can so-called define this profile. This is just an internal, basically, versioning mechanism so that we can keep track of available profile versions later. And as soon as we have done that, we can already apply this profile to our vanilla activity diagram by just selecting the root package, going to the tab profile, and add a profile application. We just select our profile that we just created, hit OK, select this profile that is contained in this resource, hit save, and as soon as we have saved that, we can directly select one of these control flows and apply the stereotype that we've just created, which is weighted flow, and hit OK. And this already allows us to specify the probability for this particular control flow. So of course, here we don't have a stereotype yet, so we can't store the value, but here we have already applied the stereotype, so we can store the value. And this is now already part of our model that we have just created, so this additional information is already stored. Of course, this is just the first step, so I've to don't bore you with looking at me creating such a profile. I have created the complete profile already, which basically looks like that. So you have here not only the weighted flow that extends control flow, but also the task that extends action, and the task can either be an automatic task or a manual task. And I've already created basically a copy of this activity diagram that I've shown you before, where I have applied this profile that I've just shown you. So we already have here specified which one is an automatic task and which one is a manual task. And here, which one, what is the probability of each of these tasks. So when I look at the properties view, I can see that this is at probability high. So for instance, when I click here on this automatic task, I can already specify, for instance, the duration, or I can specify what is the component that actually performs this automatic task. So with this, we can already represent the structure or the structural information of the model in our Papyrus diagram. Of course, this is only the first step. So we have now just extended basically UML to be able to represent the domain-specific concepts. However, if you want to create a domain-specific modeling language, you would like to do more than that. So for instance, one aspect that you would like to do is also to customize the design or the layout, the style of your diagrams. And just to show you very quickly how this can be done, I've created a small example where we also would like to have different colors for automatic tasks and for manual tasks, and we would also like to show these icons here, as well as to have different colors depending on the probability of control flows. And the way how this is done in Papyrus is a very, very convenient way, because it allows you to style diagrams using CSS. And with that, you can apply any style property, for instance, the fill color, background, the line width, whether something is visible or not, based on selecting particular parts of your diagram and then apply style properties. So for instance, here we want to, here in this example, we basically select, in case you're not familiar with CSS, maybe I should explain. So CSS basically has always a selector part and then a property part. in the selector part, you specify which elements you would like to select, and in the property part, which properties you would like to apply to the selected elements. So in this case, in this example here, we have selected all elements to which a stereotype of name automatic task is applied, and then we specify that the fill color is gray, and this would specify that these three automatic tasks have the background color gray. Just to show you how that looks like in the tool, I have already prepared this a CSS file here. And let me just close that so that we have more space here. And now I apply this CSS file that I've prepared to this diagram that we have just created, where the profile is already applied. And as soon as I drop it here, you immediately see that the style is applied. And here, in addition to what I've shown you before, we also, for instance, specify an SVG file that represents here these cogwheels, for instance, or these person shapes. One nice thing is that you can, from here on, incrementally develop this style in a very agile way. So, for instance, you can directly change here, for instance, the line color of a weighted flow with the probability high should be blue. Save that, and as soon as we refresh the diagram, we see that this element matches this selector, and that's why the line color has been changed to blue in this diagram. So that's very a nice way to implement that. You have also code completion in this editor here, where you see all the different design or style properties that you can apply. All right. So that's this is, of course, just the start of creating a concrete syntax. You can do even way more than that. So you can even replace the shape entirely and introduce an SVG shape instead of that. But this should just demonstrate how the basic mechanism works. So now, since we have extended the structure of the modeling language, of our domain-specific modeling language on top of UML based on UML profiles, and we have also created the diagram style and customized it to what we would like to see for our domain. The next part is, of course, to really create to also make the tooling to interact with those models a little bit more domain specific, because as you have seen here, even though we have just close that, even though we have applied our style here and we have created our domain specific profile, we still are basically in an UML editing environment. That means we have all these other things in the palette. We have things in the property view that we wouldn't want to use. So, for instance, an action as defined by UML can have here a local post condition and stuff, local precondition and stuff like that. Or you can you could here create just anything, basically, for instance, an output pin to this element. But in our domain-specific modeling language, we don't need those parts of UML. So how do we get rid of them and still provide a very slick tooling for editing that? So for those parts, Papyrus also supports a couple of customization points that we can use to, for instance, customize the palette, the property views, the menus, and so on. The main entry point for this extension mechanism is called the architecture model. And in this architecture model, you can specify which parts of UML you would like to reuse, which parts you would like to add. So in terms of which UML profile you would like to integrate, and you can introduce new diagram types or representation kinds, as they call it, where you can specify how which style, for instance, is applied to this diagram. What is the user allowed to drop on those diagrams? For instance, is he or she allowed to add an action or an output pin? And finally, you can customize also the property views, how they look like. And I've prepared a small example here to show you how that would look like for our example domain-specific modeling language. So in this tool, I've already implemented all those extension mechanisms. So for instance, here you only see the parts of the language that we would like really to use. You can also see that the property view has only those properties that we would like the user to be able to change, which is basically the duration, where the user can add something, or the actor that, I here I've selected a manual task, the actor that applies or is responsible for this manual task, where I'm only allowed to select actors here anymore, and I can then just select one and specify that. And finally, you also see that we have also here and in the Model Explorer all these custom shapes to represent particular modeling concepts like manual tasks and automatic tasks. So with that, we can already interact with our model in a very nice way. We can, for instance, just create a new manual task, and we don't have to create an action anymore and then apply the stereotype manual task to it. It's all done automatically by this tooling that we have created. All right. So that kind of concludes the modeling tooling part. Of course, that doesn't make or finish the entire modeling environment requirements that we would like to achieve, because as mentioned before, we would like to be able to build really a modeling environment that also integrates other tools like code generation. We would maybe also integrate it with a specific infrastructure like other data sources, and make it very easy to create models, for instance. And here we can again, since Papyrus builds on Eclipse, we can reuse all these extension mechanisms that we have available from the Eclipse Rich Client platform to, for instance, create wizards, menus, and toolbars. So just to show you that, I have integrated this in this product here already. So we can, for instance, now just create a Java project. Just call it test here. Hit next. Oh, finish. But just create a new one, a new Java project. Test 2. Maybe I had already a test project. Let's create a test 2 project. And in this project, we integrated now for Java projects, we integrated now a particular wizard that users can very conveniently invoke, the new workflow model wizard, for instance. And this workflow model wizard is a customized version of the Papyrus model wizard, where the user don't need to specify which type of diagram or which type of model he or she would like to create and which profile to apply. It's really only there to support the users in creating workflow models. And here users can just specify a name for this workflow. And then we read from a database all the actors and components that are available, for instance, as an example, to integrate some sort of other infrastructure, where the user could just select a couple of them and then hit save. And as soon as the wizard finished, you see that we automatically create a workflow model that already integrates the pre-initializes the model with the modeling with the actors and components that the user selected, and we directly switch into this I would say customized version of Papyrus, where the user can start creating elements. So this really should show you that it's very easy to also make the workflow a bit more custom, and that people wouldn't even really know that they are using Papyrus under the hood, since everything is really streamlined to a particular use case. One other thing that we also integrated in this example is a code generator. So as soon as you apply this wizard to create one of these workflow models, the project is extended by a particular code generator builder, which creates this source gen folder and populates the source folder based on what you create in this model. So for instance, in the source gen folder, you usually put things that directly represent this model and which should not be changed manually. So basically the builder overrides the entire source gen folder. And in the source folder, you only extend the source that is generated in the source gen folder in order to allow users to capture manual extensions to that source code. And so for instance, here we, in this example of a code generator, we just create for each of those actions or tasks that we have added to this diagram, we create a class. And when we look at that class, we see that it always extends this an abstract class that in turn is generated automatically for this in the source gen folder. So for instance, let's just create yet another one, hit save, and we see automatically that there two new files have been created. One thing that also, of course, is then necessary is to integrate this modeling world and the code world. And that's very easy to do with basically, on the one hand side, Papyrus, but mainly the Eclipse platform. So you could very easily just add menu items that allow you to navigate from a model element directly to the code that has been generated. So you would just have to create a new menu item and a handler for that menu item that looks up, for instance, in the generation traces, what has been generated from this model element and then directly navigate to that. You could then do the same on the Java side, but just extending the Java editor that you can click here again and navigate back to the model, which is not done in this example, but that's would be very easy to do. And you can do the same thing also if you, for instance, double click on the model element and stuff like that. So this way, it's very easy to interact with the model for users. Finally, what you get for free basically when you extend Papyrus, let me just close all that, is there is a couple of infrastructure available for Papyrus. So for instance, also diff merge and version control is available for Papyrus models. So I've created here a Papyrus, a workflow model, basically looking exactly the same. That is managed in a Git repository, and I've created a couple of changes. So let's maybe just create one more change here already. And now what I can already do is I can compare this with the head revision of the basically the last version in the Git repository, and let Papyrus compare basically diff the changes, the two versions that I have. So the changed version in my workspace with the last commit in the Git repository. And you get then all the changes that you have created. So for instance, here we have created this test shape. I've just created, in addition, this OPAC action 1 shape. Of course, there is also the semantic model element behind that has been created. Which is all already detected. And from here on, I can then accept and reject changes and make and undo them, for instance, and so on. And the same can be also done in a normal Git repository setting, so that, for instance, you merge your version with a version of another branch that someone else created, resolve conflicts and stuff like that. All right. So with that, I wanted to show you that how we typically think about integrating Papyrus. So for us, Papyrus is one of several technologies that we use as a basis for creating domain-specific modeling tools. And one thing that is particularly important to consider is that you also directly make use of the available customization mechanisms, not only in Papyrus to make it very domain specific, but also in Eclipse in general, so that you can integrate it with code generation, navigation, and stuff like that. One other thing that I wanted to mention is that the Papyrus the Papyrus community is I would say not coordinated, but is organized and supported by the Papyrus Industry Consortium. And the Papyrus Industry Consortium is basically a group of organizations that follow a common goal, and that is developing a universal and industry-ready open source model-based engineering platform based on Eclipse Papyrus and many other open source projects. So for instance, also EMF Compare and Papyrus Compare to do the diff merge. but also OCL, SysML, and the other involved technologies in the Eclipse domain. And that isn't really focused on a particular domain of usage, like systems engineering or architecture modeling and so on. So it's really more focused on the technologies. And basically how that works is that there is a strong collaboration between the different roles in this ecosystem, which are tool users, tool suppliers, and research and academia, which work together and coordinate their efforts on enhancing and evolving the Papyrus ecosystem. So just in terms of a picture, you see here that there is three types of organizations. The end users who are interested in using Papyrus or creating tools based on Papyrus. Then there are technology and service providers like Eclipse Source and research and academia organizations who all work together on a set of technologies to address a number of different aspects like collaborative modeling, trace and debug, validation, and stuff, all that. And the main idea is just to provide a forum where people can coordinate their efforts so that they can work together on a particular topic and benefit from each other and learn from each other in terms of experiences, but also in terms of reusing things that have already been done by someone else. There is a couple of different organizations involved here. I'm not sure if this list is accurate. So if you want to see the accurate list, then please follow the link that is down here. But there is a number of organizations in this consortium which together drive the evolution of Papyrus forward. Right. So since we have 3 minutes left before we have this 10-minute slot for questions, just a couple of conclusions. So in our experience, creating domain-specific modeling tools, one of the main factors of success is really the domain specificity. So that means the more you take into account how your end users in your particular domain work and what are their backgrounds, their workflows, how you can integrate that in the tool and create something that is very, very streamlined to only what they are using and nothing else. That's the key factor of success when introducing model-based engineering. So you have to really work together with your domain users to find out what their existing workflows, methodologies, and infrastructures look like, and then really blend in the modeling tool into their domain with a strategy where you try to replace a lot of tools that they already use and replace workflows with something that is more fitting for maybe modeling. That's usually not very helpful. And also just throwing an off-the-shelf modeling tool at them and hope that they will be successful often also is not very successful. So in our experience, it's best to sit together with the domain users and figure out what modeling language then they really use, and then think about how to implement that to really support their goals. And here often, as I mentioned before, the domain-specific modeling language that needs to be developed might have an overlap, often has an overlap with standardized languages like UML and SysML. If there is a good enough overlap, then it's certainly useful to or advisable to consider also Papyrus as an option to use it as a platform for creating these domain-specific modeling tools. One big benefit is that the part of UML that you reuse in your domain-specific modeling tool is guaranteed to be UML compliant. That means you can very, very easily create interoperability with other parts of UML. For instance, when one part of the organization uses something that looks very much like, or it has a part that looks very much like activity diagrams, and the other part of the organization has a domain-specific modeling language that looks a little bit like sequence diagrams, then under the hood they can connect with each other with their models because both under the hood is UML. So that's one major advantage of using UML instead of just creating domain-specific modeling languages from scratch. And obviously the other big advantage is that you can reuse what's already there. On the one hand side in the UML tool platform, but on the other hand also in the ecosystem, like what I've showed you before with Papyrus Compare, and many other things that can just be reused since you are building on top of a UML tool platform, in that case Papyrus. And finally, the last consideration, it's very important to also take advantage of the rich client platform that is underneath, which is Eclipse. Eclipse is very, very flexible and very customizable, so you can hide things that you don't want your users to see. You can add your toolbars, your views, your particular wizards, actions, and so on to really support the user in their workflows and to help them to achieve their goals with modeling, and not only to help them to model, but to achieve their goals with the models. Right, that's basically all I have prepared, and I'm very, very happy to answer a few questions. I'm sure we can share the slides afterwards, and on the last slide I've added a couple of links, so if you're interested in the demo that I've showed, the code will be available very soon. I just have to clean it up. And finally, there are some more links to the technologies that are involved, like Papyrus Compare, Papyrus obviously, and the Papyrus IC.
Thanks, Philip. That was a great demo and presentation. And of course, thank you to the community for tuning in. As of right now, we don't have any questions, but we will be monitoring our YouTube comment section, our Twitter feed, and Meetup page. So if the community has any questions, feel free to leave them there and I will send them over to Philip. So Philip, if you want to fill up the next 10 minutes, over to you. But if not, I guess we can end the live stream.
Right, Joe, I think I'm looking forward to the questions. Please just contact me at any time, and I'm happy to help people getting started with Papyrus. And yeah, just let me know.
Perfect. So everyone be sure to tune in at our next virtual Eclipse community meetup on March 28th. That will be showcasing Eclipse EMF client platform. Again, thank you, Philip, for joining us, and I hope everyone has a great day.
Thanks a lot. I enjoyed it.
Thanks.
Thanks.